Well, we're going to roll up our sleeves and have some fun right away in this course as we take a look at the command line troubleshooting tools that we have at our disposal. And a lot of these are going to be iOS functional as well, but our bias will be to the Nexus operating system, of course. Now, let me tell you, after a short discussion of just an overall troubleshooting methodology, it would be irresponsible of me to teach this course and not just quickly review a systematic approach to troubleshooting. We'll dive in and play with the tools. Now, remember, you want to really approach troubleshooting with a clear-cut methodology. And you'll often see, like 15 steps to troubleshooting a problem. But remember, you can look at this from a real high level in order to simplify it. You want to gather information about the particular problem that's been reported, normally by an end user, like we can't get to certain resources. Then you would list out potential problems, and you should probably really try and order that list based on the probability, right? So some things are going to be much more probable to have occurred than others. And then you start eliminating those potential problems that you identified. So this is an overall very high level approach that you could take. By the way, you're obviously doing certain things in this process, like listing the specific devices that are involved in the problem, checking the software versions. That's obviously going to be hugely important that are involved. Thinking about what changes have been made to the network, and how about the IP integrity of the network? I mean, do you have full reachability and things like that as you're working through this particular troubleshooting methodology? Now, it's sad, but when we are designing our data center, when we are implementing network technologies, we do want to prepare for the inevitable problems that we are going to be troubleshooting. So, some things that are really important for you to consider in preparing for these problems is, of course, documentation. Absolutely critical that as you're building and changing your network infrastructure, you are building a rich set of documentation that includes the name of devices, the IP settings of devices, the links between devices, the ports involved in the specific scenario. You may even have enterprise level software that automates the creation of that documentation for you. Something else that you're going to want to engage in is synchronizing the time across all of these devices. So we're going to use something like network time protocol in order to ensure we have that synchronization. And then you'll want to go in and set the appropriate trace and log levels on your devices so that when we start troubleshooting, we have a rich set of logging information that we can utilize in order to help us track down the potential problem. Now, obviously, a fundamental tool for us at the command line is show commands. But remember, both in iOS and as we'll see in a moment in the NXOS, we have a rich set of modifiers that we can use with show commands to make them even more powerful. Let me show you some of my favorites, and notice we are on an iOS device right now. In fact, what are we on? I don't even know. Let's see. We're on a 7200 series router from Cisco. So notice this is an iOS-based device. And on this device, you can do things like show interface, gigabit 1/0. But one of the problems you have with a lot of your show commands is you tend to be overwhelmed with output. So one of the qualifiers that we use, or modifiers, would be show interface gigabit 1/0, but we say pipe include, and we could specify like interface resets. And now notice the output. Yeah, it's one line of output now with that include modifier, and it's just the information we were looking for. How many times has this particular interface reset? So the include modifier is extremely valuable. What other modifiers might exist for me to take advantage of on this particular software platform? Well, just do this. Show interfaces gigabit 1/0 pipe, and then do your context sensitive help. So we could use the append keyword to append redirected output to a URL. How cool. Begin to start at a particular line. Exclude, okay, to eliminate output. Format. Include, redirect, just show a section of output, or copy the output to a particular URL. Now, as we're going to see in a moment, on the Nexus operating system, as you might guess, they give us even more functionality with our show commands. But hey, this is a pretty impressive list of modifiers that we can utilize in the iOS environment. So if we slide over to a Nexus 7000, in fact, let's see what we're looking at here for a platform. Notice here we're on a Nexus 7010. That's a 10-slot device running 5.2 software. And what we're going to find is a much richer set of modifiers, as you might expect. It's a more advanced operating system. Watch this. We'll do show version again, but I'll say pipe, and we'll do our context sensitive help. Notice we have the cut option to print selected parts of lines, a difference option to do a comparison. We have grep commands. What is grep? It stands for Global Regular Expression Print. So you could literally use regular expressions in conjunction with the show command. Head, in order to display the first part of particular output. Human, to convert it back to human format if you had been in an XML format. We have last to display the last lines. Less, no more. I love that. That turns off the pagination, right? So you could say show version pipe no more. And it says, okay, I'm going to just display all of the show version information, and I'm not going to stop and give you that more prompt. So a lot of rich modifiers, notice, including the old standards, right, that we love, like the include command and the exclude command, but a much richer set of modifiers in the NX OS environment. Now, we just can't have a nugget dealing with CLI tools without, of course, mentioning Packet Internet Groper, ping. And we have ping in the Nexus environment, of course, and notice we can specify a particular virtual routing and forwarding instance. So we can name that particular VRF, and then there's lots of great options that we can utilize with ping, like packet size, an interval, and a timeout value, and how many ping packets that you want sent. So ping is going to be critical for us. Just like in an IPv6 environment, we can utilize ping 6. So ping 6 is going to follow a similar methodology. We are going to provide the IPv6 address that we are interested in pinging. We can specify our particular VRF. We can specify a particular count. Something else, now it just really wouldn't be right for us to have a ping command without having a pong command. So here is the pong command. And notice pong is all about measuring the port-to-port delays in your data center. It relies upon the IEEE 1588-2008 version 2 Precision Time Protocol. That's PTP in order to operate. The Pong utility is very similar to the network monitoring utility ping, but notice it's going to give us a richer set of metrics specifically regarding delay information. Pong utilizes synchronized clocks in the network to measure the real-time latency we're experiencing. Now, you can enable the Pong utility on the Nexus 7000 F1 and F2 series module ports. Notice the M2 series module ports are going to support this feature as well, but you do need to use the feature Pong command in order to enable it when you're in the M2 module environment. And of course, we love traceroute. Remember, from an IPv6 perspective, we have now traceroute 6. So these are going to be used in conjunction with each other in IPv4 and IPv6 environments respectively. We know we love traceroute because it is going to show us the hop-by-hop path that our data traffic follows, and it's also going to give us latency information as well. Not as sophisticated as the Pong utility, but still a quick glimpse at hop-to-hop latency. Now, time for a quick power tip about many of these tools. What'll happen is you'll run a trace, for example, and that particular destination is not reachable. And so you're seeing the asterisks appear here and it's taking forever, and you realize, oh, I typed the wrong address. So you want to escape out of the use of that tool quickly. In order to terminate many of these commands, we're going to go ahead and do a Control C on the keyboard in order to break out of the particular command that is running. This applies to things like pings and traceroutes and Pong, a lot of the tools that we have mentioned in this section. But wait a minute here. What if we're in a fiber channel environment in the data center? Well, no problem. Fiber channel ping, FC ping, is going to verify reachabilities of nodes for us. And fiber channel trace is also going to provide functionality for us to literally trace the route followed by data traffic in the fiber channel infrastructure, and also to give us the hop-by-hop latency. Notice we can utilize something like a fiber channel ping command and reference a port worldwide name, as you can see I'm doing in this example, or you could provide device alias. When you do an FC trace, once again, we can provide the fiber channel ID, the port worldwide name, or the device alias as a particular destination. Now, the CLI commands that we've been seeing up to this point are certainly extremely valuable, but there are better show commands that we can utilize for monitoring things like the system and processes and the CPU. In fact, if we go to a device, and notice this is an iOS device, by the way, so it works in that environment too. And we do a show processes question mark. Notice that we can see CPU information. We can see memory information regarding this particular system. Now, one of the show processes variations that we absolutely love is show processes CPU history. Notice this gives us a graphical representation of the CPU's utilization over the last 60 seconds, over the last 60 minutes, and over the last 72 hours. Notice in this graph, we have the CPU utilization on the left and then time going along the horizontal axis. And you can see for the last 60 minutes, sure enough, in this particular time interval, we were a bit utilized with the CPU, about 10% utilization there. So you can see these hash symbols are going to be showing you the CPU utilization for that particular time frame. Now, we certainly didn't have any concerns about CPU utilization in my little lab environment, but let's say we did. What would be a good way to track down what the issue is when it comes to CPU utilization on your device? Well, another just hugely awesome command. Watch. We're going to do show processes once again. We're going to do CPU once again, but we're going to say sort. And it's going to say, okay, look, these are the processes that are consuming most of those CPU resources. And sure enough, EIGRP IPv4 hello is right in there. Now again, my CPU utilizations aren't a problem, but you could see how this command would be very beneficial in an environment where you were having an issue. Another excellent monitoring command that you're going to find over on the Nexus operating system side of the house is the very convenient show system resources. Notice this gives us a really nice quick snapshot of system-related CPU and memory statistics. The load field is defined as our number of running processes, and the average reflects the system load over the past 1, 5, and 15 minutes, as you can see. The processes field displays the number of processes in the system and how many are actually running when we issue this command. The CPU states field shows the CPU usage percentage in user mode, kernel mode, and idle time in the last 1 second. And finally, the memory usage field provides total memory, used memory, free memory, memory that's used for buffers, and memory that is used for the cache in kilobytes. Buffers and the cache are also included in the used memory statistics. Now, speaking of monitoring, we do need effective ways in which to monitor data. And you probably know one of those methods is called the Switched Port Analyzer, or SPAN feature. The SPAN feature is often referred to as port mirroring or monitoring, so don't be surprised if you see it that way as well. The idea here is you're going to take the switching process. Let's say this is our, we'll just call it the 1/1 interface, and this is the 1/10 interface. We know that if we plug a network analyzer into the 1/11 interface, this network probe is not going to be able to hear the unicast communications that's going on between the devices in 1/1 and 1/10. That's by design, because that unicast transmission is not flooded out to 1/11. So when we mirror or monitor these particular packets, they are copied to this particular span destination port. Now, you want to be able to do this across multiple devices. When we're doing it just locally on one device, that's when we reference it as span. But if we're doing it across many devices, we refer to it as remote span. Just be aware that some of your various devices are going to have, well, different capabilities when it comes to span. For instance, remote span is fully supported on the MDS switches, but on something like the Nexus 7000, we can use our span across it, and we could pull data off of the RSpan VLAN, but we can't place data onto the RSpan VLAN from the Nexus 7000 switch. So when you're working with these different data center switches and iOS-based switches and MDS devices, you're always going to want to check the particulars on a particular feature like remote span to make sure you're aware of any limitations that your particular device and operating system might possess. Now, you are responsible for the configuration of span, and let's take a look at an example in the Nexus OS environment. Notice we go to the Ethernet 1/11 port in this case, and this is going to be our span destination port. So we have to utilize the switch port monitor command. Once we've made this configuration change, we're ready to set up the span. We go into Monitor, Session, and provide a locally significant session number here, Monitor Session 1, for example, and we say, where do we want the traffic we're replicating to come from? Here I say VLAN 10. Let's grab the traffic off VLAN 10. Let's go ahead and also grab the traffic off this Ethernet 1/9 port. Now, maybe this 1/9 port's a trunk and there's lots of VLANs worth of data traveling over this. Here we can filter that just to specific VLANs. So I could say, I want information just from VLANs 10 through 12. Where are we dumping this? Where do we have a protocol analyzer, for example, ready to analyze this information? Well, we're dumping it to Ethernet 1/11, as you know. We no-shut this particular span session. Where would you find this configuration? Well, let's go in and let's make sure we can find this configuration in the Cisco documentation. This is a tales from the trench moment, because obviously the configuration of span might vary from Cisco device to Cisco device. So for your specific device, you would want to be able to find this configuration quickly. Now, since this is a Tales from the Trench segment of this nugget, I am unrehearsed. That's right, you're going to see me try and find this feature, and I have not practiced this for this particular nugget. You ready? Support all products. I love this initial interface. And now let's say switches under products and data center switches. And let's say we're on the Nexus 5K. So we're on the Nexus 5K. We're on the 5548P. And I sure hope it supports span. Otherwise, this is going to be pretty embarrassing. We go to configuration guides. And then look at this. All of these particular chapters for this particular device. So I'm looking through, and where would span most likely fall? Maybe system management, maybe fundamentals. I'm thinking it would most likely fall under system management. And look at this, we have span as well as ER span, something we're going to be talking about here as well. But we go to the span section and it says, all right, here's your documentation on span. And here we see creating and deleting a span session. This looks excellent, and it's going to walk us through the creation of our span session. Notice, switch port monitor under the port that we're going to dump the traffic to, the monitor session command, the destination interface command, and the configuration of multiple destination ports. All kinds of great documentation in here for that specific platform that we might be working with. And by the way, notice the verification of your span configuration is very simple as well, thanks to the powerful show monitor session command. Here I can verify the state of my span, and I, most importantly, see that I'm going to be capturing, for instance, from Ethernet 1/9, both received and transmitted traffic. And I'm also going to be grabbing the traffic off of VLAN 10. We see our filter configuration and we see our destination port configuration in this powerful show command. But then came along a technology even more powerful, giving us more flexibility, and that is encapsulated remote span, or ER span. The idea here is take this mirrored traffic and encapsulate it in GRE. Now we can send it over IP-based networks, and we have much more flexibility, obviously, in where the particular probe is located to grab the traffic. Notice in the NXOS environment, globally, in the default virtual device context, you would go in and you would set up the origin IP address. So monitor ER span origin IP address would set that and use the global keyword. Then you can go in and configure your configuration for sourcing the session. Here we create an access control list. For example, we set up a monitor session 1 of type ER span source. We do our source interface, our source VLAN like we did before, a destination IP address, and then mandatory, we need to go ahead and set a ER span ID, indicate the virtual routing and forwarding table, and no shut the monitor session. By the way, you can apply an access list that we created earlier in order to produce particular filter results. So this would be all of the configuration that we would need for sourcing the encapsulated remote span. And then here you can see our configuration over at the destination. Not really much different going on here, right? Switch port monitor, because it is a destination port. We then set up our monitor session with the type ER span destination, our source IP address command, the destination interface command. We need to reference once again the ER span ID and the virtual routing and forwarding table, and then a no shut. Verification of the ER span configuration would be the show monitor command once again, just as we did with a more classic span configuration. But at this point, admittedly, you might be a little bit underwhelmed. I mean, after all, we have been using span and even encapsulated remote span in our switched infrastructure for a long time. Well, this might spice it up a bit. How about if you had Wireshark functionality built right into your NXOS? Well, guess what? You do. Yeah, it's a feature called the ETH Analyzer. And this feature is leveraging the fact that the NXOS software is based on a Linux kernel. This Linux kernel supports capturing using the libpcap library, and Wireshark, of course, can decode packets in this format. Basically, this ETH Analyzer feature is really NXOS's wrapper over T-Shark. And as you probably know, T-Shark is the text-based version of Wireshark. So we have this functionality built right in the NXOS. Now, please keep in mind, this analyzer can capture and analyze packets received or sent by the supervisor engine through the out-of-band management interface or the in-band fabric interface on the supervisor engine. Now, there's other limitations here. For instance, on the Cisco Nexus 7000 series switches, this ETH Analyzer is only going to be available in the default virtual device context, as it allows control and management plane traffic from all VDCs to be captured. Because it's based on Wireshark's, keep in mind it's going to support the same set of powerful capture and display filters that we have available in Wireshark. So I'm sure you're going to want to see an example of just how easy it is to leverage on, let's say, a 7000 series. Let me show you an example in which we capture traffic from the in-band fabric interface of the SOUP and literally display a number of captured frames with this technology. I mean, could it really be leveraged with a single command? Yeah, you got it. Look at this. We're on the Nexus 7K here, and we say ETH Analyzer, local interface in band, and then limit captured frames to 5. By default, the number of captured frames on this platform is going to be limited to 100, but we can easily manipulate that. And then look at this. Those frames are indeed shown to us. Now, you might say, wait a minute, that's just header information of those particular 5 frames that we captured. What if I wanted more details? Well, you would add the detail keyword to your command. But I know what you're saying. You're saying, Anthony, I don't want to sit there and see the information at the CLI. I would like to go ahead and capture traffic and then write it to a file and then pull up the graphical user Wireshark later on and analyze that file. Okay, I don't blame you. So let's take a look at an example of doing just that, doing a capture and writing it to a file. So here we are, ETH Analyzer, local interface, in-band, write to boot flash, mycapture.pcap. Now, we are not given output at the CLI. The information's tucked right into that boot flash file that we named. Gotta love it. By the way, you could also use the redirect symbol. So you could say ether analyzer local interface, and maybe you could say the detail keyword, and then you could use the greater than symbol, and you could say like my cap.txt. So that would allow you to redirect the output to a text file, but unfortunately, Wireshark wouldn't be able to read that text file. So, sure, there are alternatives, but exporting and writing into a PCAP format is going to ensure that we can pull up Wireshark, or for that matter, some other network analyzer, and interpret your results. Oh, and by the way, if you did want to take one of your captures, here we've created one called capture.pcap earlier, for example, and read it locally, display it at the CLI, you could. We're just going to say read, that read command. We're going to specify the particular file. And then if we wanted to get the details of those captured packets, we would say detail. And that would allow us to literally analyze the results at our CLI. Believe me, as you might guess, the graphical user interface of Wireshark, the app itself, is going to be a much more robust way in which to analyze that traffic. But it's nice, in a pinch, we could check it out at the CLI. Now, we can obviously learn a lot about what's going on with the system from logging as well. Now, I won't bore you with the fundamentals of logging. You learn this in CCNA, like the logging levels and what's in a logging message. But I will tell you that things are going to vary as far as defaults based on our platform. So we would want to check the documentation. For instance, on a lot of NXOS devices, you're going to have messages of a severity level of 2, which is critical, or lower, be automatically logged to the supervisor console. The last 100 messages of this severity level 2 or lower are going to be logged to the NVRAM of the switch supervisor, and messages of severity level 5, which is the notification level or lower, are going to be logged to a log file in Flash. Now, you can certainly change severity levels, file names, and file sizes of the log file in Flash, for instance, but the NVRAM logging behavior is typically not configurable. You can use the show accounting log command in order to see the history of logins and configuration changes. If you're wondering what capabilities are available and what you can set, just do the logging question mark like we would in an iOS environment to see the potential configuration options. If you want to look at the messages, obviously you're going to use a show logging type of command, and maybe you'd say something like show logging NVRAM last 3, for instance, to see the last 3 messages that were logged to NVRAM. You could do show logging log file and then use particular parameters in order to view the log file in Flash. And maybe you want to view them from a certain timestamp. All of this is easily possible at the CLI. Now, one area where Cisco really did their homework, though, when it comes to logging is called on-board failure logging. What a great idea this was. This is persistent storage. And sure enough, you can go ahead and view this. And this is where we're going to find things like, oh my goodness, the initial temperature of modules, stack traces for crashes, CPU hog information, memory leak information. And again, it's going to be persistent. So what you would do to view this information is you would do your show logging command and follow that up with the onboard keyword. So this will allow you to see the onboard failure logging information, which might prove critical. Oftentimes, though, as you might guess, is we're going to need the Cisco's Technical Assistance Center in order to help us analyze the information in the onboard failure logging area. So now you're probably starting to really appreciate the robust set of CLI tools that we have, and we're not done. That's right, there's the Cisco Generic Online Diagnostics. This is a suite of diagnostics that verifies the hardware and internal data paths and make sure they're operating as designed. We get boot time diagnostics, continuous monitoring on demand, and scheduled tests as part of the Cisco Gold feature set. The diagnostic framework can detect hardware failures while the system's online and operational, and corrective actions can be taken through the EEM policy that you can create. Keep in mind that each module you have in your data center might have a different set of tests that are built in. So Cisco Gold will use the Cisco EEM framework to react to failures. The 7000 series switches ship with a set of system default EEM policies that include the Cisco Gold default Cisco EEM policy. The common default actions for these policies include disabling the test and then triggering the corrective action. For example, maybe the particular ports will be placed in the error disabled state, or maybe the entire module itself will be reloaded. Now, what you'll find is on your gear, like the Nexus 7000, a full set of gold tests is going to run at the system boot up. You can go in and you can use the command diagnostic boot up level and then use your context sensitive help to see all of the available options that are there for these boot up diagnostic tests. And of course, there is non-disruptive tests that are scheduled to run in the background at regular intervals. You could literally go in and manipulate the schedule of these tests. Once again, the command would start with diagnostic, and then in this case, you would say monitor interval, and then you would go ahead and specify the module number and then the test number. And then you could go ahead and set your hours, minutes, and seconds. Obviously, use context-sensitive help with any of these particular commands to get the particulars. You could even use the command diagnostic and then use the keyword on demand in order to go ahead and literally initiate tests immediately. Maybe you're wanting to test a specific hardware component in order to locate a particular fault. So we have the ability to schedule these powerful tests on demand as well. How do you display the currently configured boot up test level and the current schedule? Well, the command that you're going to utilize is show diagnostic content. So the show diagnostic content command is going to indicate the characteristics of your tests. Another really nice feature on a lot of the equipment these days is the blue beacon feature. Yeah, it's an LED. A single blue LED is available on the removable parts like the fan trays, power supplies, and modules, and you can make this thing blink. This tells the technician that's coming in behind you the exact component you want them to work with. So in order to flash the LEDs on a hardware entity or to flash a single port LED on a module, you can use the command at the command line locator -LED. So check out the context sensitive help with locator LED. You can indicate particular power supplies, modules, fans, chassis, crossbar fabrics, and all of this support is in addition to simple network management protocol support. Sure, the NX OS software is going to support version 1 of SNMP, version 2C, and the version 3. What's the big deal with version 3? Yeah, you got it. Security. This is the version of Simple Network Management Protocol where security is really present. We used to joke about SNMP, of course. Security's not my problem. But that all goes away with version 3, where we can enhance the security dramatically. Remember, SNMP over IPv6 is also supported. And in our Nexus 7K environment, we can have one instance of SNMP per virtual device context on that particular system. And you might have the Simple Network Management Protocol interacting with Embedded Event Manager that I mentioned earlier. If you haven't checked out EEM, be sure you do that. This is an incredibly powerful tool where you can not only monitor things, but then have applets run that will do particular things based on the information that you are monitoring. Another tool that we have at our disposal at the CLI that's based on SNMP is remote monitoring. So we can do full, that's RMON, by the way. We can do full RMON capabilities inside the Nexus environment as well. And we wouldn't be able to talk about CLI tools for troubleshooting without talking about debugging. Sure, we're going to have powerful debug capabilities in the NX OS as well. Now, you'll definitely want to do very specific debugs. If you ever went up to a Nexus device and you did the debug all command, get ready, because you're probably going to create major problems. Debugs are great, of course, because at the CLI we can see as close to real-time information really as possible. And the debugs you have, of course, are going to vary on your Nexus OS device based on what feature sets are enabled. Remember, we have the feature command in the NX OS where you literally turn on particular features, and that's going to directly impact the scope of your debugging. Remember to always consider where you're putting the debug output. Maybe you're going to bring it to the screen. Maybe you're going to bring it to a telnet or secure shell session. Maybe you're going to bring it to a data file and switch memory. Really think about that. Obviously, you need to have administrator privileges to do these debugs. And the good news is you'll have time stamping and a listing of the debug chronologically, let's say if you were to create a file. One of the great things to remember is the all command. This is undebug all. You could also say no debug in the Nexus environment, and this turns off this debugging, which is obviously very important to do from an overhead perspective. And it's really great because the commands that you're using with debugging are very intuitive. For instance, debug log file, and then you can go ahead and specify the name of your file. This is how easy it is going to be to set up a specialized log file for capturing your debug output. Then all you got to do is a show debug log file in order to view the contents of the debugging. And one of the most frequent problems with debugging is being overwhelmed with the amount of information that you receive. So you could always go in and say, all right, debug hyphen filter. The debug filter command is going to enable you to add unwanted debug information that you're going to filter out. For instance, you might go in and say debug filter IP EIGRP interface Ethernet 2/1. This would limit the EIGRP hello packet debug information to that specific interface. So you could go in and say debug filter IP EIGRP interface Ethernet 2/1, debug EIGRP packets hello, and now you're going to be debugging that EIGRP information, but you are going to be limiting it to the criteria that you specified. Very, very cool feature. And the very last but not least tool that I would like to mention that we should want to take advantage of at the CLI is our event history utility. This is for all features. This is so cool. You can walk up to your Nexus and you can say show IP EIGRP internal, and then same command, event history. And I could say errors. This displays EIGRP error events for our particular autonomous system. This is so cool. It's like having a debug running all the time. So if you're looking for the root cause or historical context for a particular problem, you can go in and you can see the errors of a specific nature that have occurred thanks to the event history utility. So what an incredibly robust set of tools we have at the CLI. Obviously, as you get a sense for, this particular video could have gone on for 5 hours had we gone into every one of them in depth at the particular CLI itself. But it was our intent here to give you the broad overview, let you know about all the tools in your tool belt, and then of course we can use specific tools later on in this course as we are troubleshooting specific technologies. I sure hope this nugget was informative for you, and I'd like to thank you for viewing.